continuity. Why is continuity important? Because it tells us when we can actually differentiate a function. A graph that has no vertical asymptotes, point discontinuities, any other gap in the domain that you could think of, is said to be continuous. So here's some examples of discontinuous graphs. So the classic ones are our hyperbola. It's got a gap in both the domain and the range. So that's not a continuous graph. There's one of the ones that has a point discontinuity. So x over x as opposed to just drawing 1, because you can't substitute 0 into the bottom of the fraction. So x can't equal 1. So that's not continuous. Well, the ones where we sort of have the function split into two functions. Again, that one's not continuous. So they're all discontinuous graphs. Why is that important? Differentiability. In order for a function to be differentiable at a particular point, the curve needs to be what we call smooth continuous. So it has to be continuous, but also smooth. And that also means that the tangent can't be vertical, because the derivative has to be defined as well. So an absolute value graph, well, it's smooth continuous everywhere except at x equals 1, because you've got that sharp point there. So that particular one, it's differentiable everywhere except at x equals 1. And I suppose another way of thinking about that is by looking at the graph, what would the tangent be at x equals 1? Well, it's a bit hard because it's a sharp point. Is it going straight down like the line, or is it horizontal? We don't know, and that's why you can't differentiate it at that point. There's the sideways parabola, but it's not differentiable at x equals 0 because of the vertical tangent. So the derivative is undefined, so it's not differentiable. Something like this, it's an unusual sort of a graph, but again, it's not smooth. This one is continuous, but it's not smooth at x equals 2. That's what we call a cusp. So when something comes down to a sharp point like that, we call it a cusp. So that's not differentiable at x equals 2. Also, it disobeys the vertical tangent rule, because if you were to draw a tangent in there, it would be vertical. Okay, very quick bit of theory for today.